Hey guys, we're going to take a moment to learn about getting new functions from old functions. And on this slide, we're going to be focusing on composition of functions. But to kind of roll into this concept a little bit gently, let's start with this problem that we've done before. Find f of 4. So what does that mean? They give us f of x up here, find f of 4. And what it's saying is we have a rule up here that takes an input, x, and gives us an output, f of x, right? And it's so saying, what's the output when you give it an input of 4? So what we'll do is we'll come up, the way we can think of it is coming up to this function up here and replacing every x that we see with a 4 to calculate it, right? So with this function, we would have 2 times 4 plus 3, and you could calculate that out to be 11, right? Down here, though, what are we doing? We haven't probably seen something like this before. But what it's really asking us to do is to replace every input that we have. Instead of x, what I want to do is replace every input with 2x. And so something that might help you a little bit here is come up here and let's put square brackets around every input. All right. So basically, whatever I put in here, every time I see a square brackets over here, that's what I'm going to be writing. So let's write down my function with just the square brackets though. All right, so 2, and then I want the square brackets plus 3. Okay, now but what do I put inside these square brackets? Well, to see that we have to come over here, right? We put the square brackets here, and we see, oh, you know what? It wants me to put a 2x there. And so if I simplify this, 2 times 2x is 4x. I'll get 4x plus 3. Right? Now this looks even worse, and this is where we really get into composition of functions. One way we'll read this is f of g of x. Sometimes they might write it out with a little circle here like f of g. Right? But let's just apply the same technique we applied here. All right, so let's start with the square brackets. We want to write out this is equal to 2 times whatever my input is. I'm just looking at this right here. 2 times whatever my input is plus 3. Now to figure out what my input is, I do the same thing I did before in part B, and I come here and I draw square brackets around my input and say, oh, you know what? I should be replacing what's in the square brackets here with g of x every time. So for now, we could just start by writing g of x. All right, and the way we can finish this off then is come up here and say, well, what actually is g of x? Well, it turns out g of x is 4x plus 7. So I can write 2. Can leave the square brackets there for now because I'm kind of still replacing the input. 4x plus 7, and then all of that plus 3. And now to work this one out, I have to make sure I distribute the 2, and so my final answer would be 8x plus 14 plus 3, or this is 8x plus 17. Okay. Now to do the same thing down here, let's put square brackets around our input and just do the same thing we did before, except we're going to do it with g, right? So let's put square brackets around our input. And so g of something. So g of something. So what's g of something look like? Well, what g does is it takes 4 and it multiplies it by your input, right? And then it adds 7 to it. Now, what is the input here? Up here, the input was x. What is the input here? The input down here is f of x. And so we could simplify this a bit. And so we could say 4 times, and then just plug in all of f of x, so 2x plus 3. And then we're adding 7 to it, right? And so our final answer here will be 8x plus 12, because I still have to distribute, and plus 7, or 8x plus 19. And now notice that both these things, f of g of x, replacing the input of f with g of x, is not equal to g of f of x, where we're replacing the input of g with f of x. And that's usually going to be the case.